At this point, we have seen two examples which we could not solve because our variable was in the exponent. We need a way to undo exponents. In other words, we need an inverse function for exponential functions. Recall, a function has an inverse if it's 1 to 1. And we saw that exponential functions are 1 to 1. So we can conclude that exponential functions have an inverse. Now, none of our current functions are the inverse of exponential functions. So we need a new function. We call the inverse of an exponential function a logarithm. And remember, we have a different exponential function for each base b. So this means we have a different logarithm for each base b. And we write the logarithm with base b as y equals log sub b of x. Now, since logarithms are the inverses of exponential functions, we have that log base b of b to the x is just x. And b to the log base b of x is x as well, because these two functions undo each other. They're inverses. Furthermore, if we use that y equals b to the x, then we can rewrite the first equation as x equals log base b of y, which goes hand in hand with our original statement that y equals b to the x. We will want to go back and forth between these two statements interchangeably to be able to work the best with exponentials and logs. As one final note, the domain of our logarithm is the range of our exponential function, which we saw as all positive numbers from 0 to infinity.